Hello everyone, so welcome to the very first class of SPSS. I am Huzafa Arshad, your instructor for the whole course. So today we'll be learning all about the introduction of SPSS, where it came from and what actually SPSS stands for, what is the importance of SPSS when it comes to academic research, and what is the prevalence or what is the usage, how much researchers actually use SPSS in today's world. So SPSS stands for Statistical Package for Social Sciences, right? So this software came at very early around in 1968. The first version of the software was launched back in 1968, and the current version was launched, which is SPSS 26, was launched on 19th April 2019. So we can see SPSS is a very time tested software, and it has been used for more than 50 years onwards. So the SPSS was developed by three students from the University of Stanford. So originally SPSS was a property of SPSS Incorporation, which was founded back in 1975, and then later it was took over by IBM in 2009 at around $1.2 billion. So however, coming to the usage or coming to the importance of SPSS today, as you can see, most of the academic research uses analytical software, and these analytical software, it is a high probability that these analytical software might be SPSS. Let me introduce you to the latest version of SPSS, that is SPSS 26, how it looks like and what are the functions. Okay, so here we can see that this is how a SPSS sheet look like. So we have two types of view. We have a data view, we have a variable view, right? And then further we have a one more window which says output window. So we have a output window, and then we have one more window which has two tabs in it, that is data view and variable view. Now let's understand what these different um, things, different rows and columns mean, what these icon means, and so on. So in SPSS, all the columns represents a particular type of variable. Okay, so we can say that maybe a column 1 maybe the column for name, the column 2 maybe the column for age, and so on. The third column may be gender. So each variable is represented by a column in the data view of SPSS spreadsheet. Further, each rows represents the case, for example, person A of particular age and a particular male or female gender. Okay, so each row, we can say each row represents a case in the data sheet. Okay, so this is a very blank spreadsheet which we can see here. So let's start by entering some variables here. Okay, so we have a variable view. We cannot directly enter different variables in the data view. Rather, we have to first define the variables, and then after that we have to further insert the cases in a particular variable. As we can see in one of the file which we have created, we have IDs, birthdays, and the gender, athlete, height, weight, smoking habits, and multiple variables listed in the columns. And further, we have different cases which have been inserted in these rows and a particular column under the different columns. So we can see that row 1 is a particular case which has a particular ID, has a birthday on this date, and is belongs to this gender, and is an athlete or not, and is of this height and this weight. So each row represents a particular case, whereas each column represents a particular variable. So further, since now we know that what the data view what the rows and columns mean, let's come to the variable view. So view looks more or less like this. And let's come to the fresh file so that we can understand what different fields are for, what the different columns are for. So we have to first define the variable in the SPSS, and then only we can input our data in the variable view. So first we have to tell the file that what variables we are interested in, what variables we are going to take, and what will be the type of the variable, whether the variable will consist of alphabets or it will consist of numbers. Further, we have to tell whether there will be what will be the length of the variable, how many characters it will contain. We have to tell whether there will be decimal places or not. For example, if it consists of something like money, there may be decimal places. The data will have decimal places. If it is something like age, it generally won't have decimal places. If it's something like name, there's obviously it won't have any numbers. So we have to tell the system that what is a variable, what is the name of the variable, what is the type of the variable, what will be the width or the number of characters it should contain, whether there will be decimal points or not. Okay, so the first four columns are name, type of the variables, and width and decimals. Okay, so let's understand this with the help of a already created file. So we can see here we have four variables. The first variable is ID, the second variable is birthday, the third variable is rank, and the fourth variable is gender. Okay, so coming to the data view, we can see these variables listed under different columns. Okay, so we have ID, birthday, rank, and gender. Okay, so let's see what the variable view has to say about these variables. So the very first variable, that is ID, is a numeric type. So we are telling it to the system that we are going to enter numbers for different ID. Okay, so what the variable will be consisting of. Further, how many numbers will it consist? For example, there will be 5 numbers. There will be no ID with more than 5 digits in it, more than 5 characters in it. So if we put an ID with more than 5 characters, generally it won't take it, it won't accept it and automatically delete one or more character which is extra. Okay, so further moving ahead, we have the second as birthday. So if we click here, we can see we have different types of variables here, right? We have multiple options to select. There is numeric, comma, dot, scientific notation, date, dollar, custom currency, string, and restricted number. So technically, make sure, try to understand that these are not different variable types, rather there are only two types of variables which may be present, that the one is numeric and the other is a string. The other options are just variable formats. All the other options including dollar, date, all these options come under numeric data. Okay, so technically we have only two types of variables. The very first is numeric and the second is string. So in this way, what we can do is we can give different, we can assign, or we can make the system understand what type of variable are we dealing with in a particular research. So generally string variables, we cannot perform any computation on string variables, like any type of computation, any type of analysis or basic analysis on string variables. Okay, but when it comes to numeric variables, most of the computations can be performed. Okay, moving ahead, we can see we have something named as decimals. So these decimals represent the decimal points, whether there will be decimal points or not. For example, we can see that there is a variable named height. This height contains decimal point 66.92. Suppose if we remove these decimal points from height and change it to 0, then we will see that our data has changed and has lost its values beyond the decimal points. Okay, so moving ahead, we have something called labels, values. Let's try to understand what these different columns mean. So for example, we can see here that um, here gender has been mentioned as either 0 or 1. So we don't know, actually the system doesn't know what it means, what it should mean by 0 and what it should mean by 1, whether 0 is male or whether 1 is male, or 0 is female or 1 is female. So the system is not very clear. So in these cases, or even when we are using some sort of scales like Likert scale, where we have different uh, attitude in a continuum, for example strongly agree, agree, neutral, disagree, strongly disagree. So all these things, how will are we going to make the system understand that what we mean by giving 0 or 1? So by simply assigning a value to the different numbers which we have inserted, we can make the system understand what we mean by the value. For example, if we say that 0 is nothing but male in this case, and just we add it, and we can say that by 1 we mean it's female, add it. So and we can click OK. So now the system knows that when in gender variable, in a particular case when we insert 0, what it should mean, and when we insert 1, what it should mean. Now the system will understand that 0 stands for male and 1 stands for female. Further, coming to the label part. So label can be used in multiple ways. Sometimes it is used when we have a very long name of a variable. For example, let's create a variable which has a long name. For example, let's say youth happiness index. Youth happiness index. Okay, so let it be a numeric one. So we can see that the name of the variable is quite a big one, and when it comes to variable, when we go to variable data view, we see that it's taking a lot of space, and we may also have a problem in reading. Or it may sometimes be that we have listed items or questions or variables in a different way, like question 1, question 2, question 3, question 4. We don't know what the question 1 is trying to measure, we don't know what the question 2 is trying to measure. So in both the cases, whether if there is a long variable name, or if there is some, we have items like question 1 or question 2, we have named the items like this. So what we can do, we can use this label column, and we can just write here, for example, we can just write here that rename the variable as YHI, and we can write in the label section what it YHI means, that is youth happiness index. Also we can use, for example, if we have uh, named a variable as question 1, question 2, question 3, then we can represent the dimension to which this question belong to, the factor to which this question belong to. For example, question 1 may be a question related to wealth of a person. So we just write down, we just note what is the label or what is the dimension to which the question belongs to. So we can see that label can be used in multiple ways. Further, we are clear with labels, we are clear with values, and then coming to the column, alignment, measure, and so on, and missing. So first let's go to missing. So we can see in the data view that in practicality, whenever we collect any data for a research, there are always some cases which where the data is not available. Maybe the uh, respondent uh, has wished not to answer the question, or just carelessly omitted the question, or so on. So anyways, if we have any data which is missing, so it is going to affect our analysis. So we have to tell the system what to do with this missing data, what to do with this missing values. So what we can do, we can just go to the variable view, and we can, for a particular variable such as gender, so we can tell the system what to do with the missing value. So we have different options here. We'll be discussing the options in our further classes. However, we are leaving it for now. Further, we have columns. So here the columns literally mean the width, or what will be the breadth of the column. So let's see, for just check the value here written. It's written here 10. So the width of the column, first column, that is ID, is 10. So if we go to the data view and just increase the width a bit, and then we go again to the variable view and just check, so we can see that the column width has changes. So technically it means how the column is represented, how much space, physical space, it is going to take on a system, on a screen. Just it means. Further, we have something called alignment. So this is a very basic function which we have been using in most of the MS Word and MS, most of the Office softwares. So alignment is nothing, just we let the system tell, we so alignment is nothing, just we tell the system whether our variables, whether our data should be left aligned, or right aligned, or center aligned, left aligned, right aligned, or center aligned. Okay, so align refers to how our data is going to align in these particular columns. So we can see that here the gender is right aligned, and if we change the alignment of gender, then it will be, for example, let's make it center, then the alignment is going to change for the gender. So it's just for convenience how we want the alignment to be. Okay, further, we have something called measures. Now measure is a very important attribute to define, because whenever we are taking any variable, we have to let the system, we have to tell the system that what the variables, which level of measurement the variable belong to, whether it belongs to the nominal measurement, categorical measurement, or it belongs to the ordinal measurement when we where we give ranks, or it belongs to the interval or ratio scale. So we have to tell the system what is a level of measurement, what is a scale of measurement for a particular variable. For example, if we have categories like male, female, then it is better to select a variable as nominal. If we have ranks, for example, here we can see a system is rank, a third variable is related to rank, something which is ordered as in a rank, where we have given rank. So what we can do, we can just select the measure as ordinal. Further, if there is a continuous scale on which a variable has been measured, then we have to select the variable type or measure of the variable as a scale. It can be a Likert scale, although, or it can be any physical scale like centimeters, meters, height, weight, etc. So so we have, it is very important for us to define the variables properly and to let the system know what measure it belongs to. On the basis of this measure, the system will be able to, we will be able to conduct different analysis on different variables. Otherwise it may say that a particular variable is not fit for a particular analysis. So it's very important to define the variable measure. I think we are clear with both data view and the variable view of SPSS. Now, a very brief intro about what the output window or the IBM SPSS statistics viewer output viewer has to do. So technically, whatever analysis we are going to run in here, the reports, the results are going to pop up in the output. So let's do a very simple analysis. Let's check the frequencies or how many cases are there in a particular variable. For example, let's see gender wise, let's see how many males and how many females are here in a sample. So whatever analysis we run, whatever analysis we are going to run, our output is going to, our results is going to pop up in the output section, output window. So it says that we have 426 samples, out of where there were valid samples, and 10, there were 10 cases where the gender was not mentioned. So out of 426 people, 204 sample was male and 222 were female. So approximately 46.8% of the sample is male and 50.9% of the sample is female. And obviously there are 10 missing samples. Then there are 10 cases where we do not actually know what is the gender of that particular case. So I hope this introduction to the SPSS is clear to you, and further we will be meeting in the next classes and we will be going further to what these icons here mean in the SPSS. Further we'll be learning what are the different functions, what are the different types of analysis which we can run in SPSS and so on. So thank you very much. I hope you liked the class and today's lecture has contributed to your knowledge.